Let me read the question now. A company produces a type of potato chips and packed them before being marketed. The mass of a packet of chips ranging from 75 gram to 80 gram will be accepted for marketing, while the mass of a packet of chips that is out of that range will be sent for repacking. Table 2 shows the mass of a packet of chips and the number of packets in ratio at a particular time. Okay, so in the table 2 they already give the mass and the number of packets in ratio. So from here we know that the mass of a packet of chips that range within 75 to 80 gram will be accepted. Anything more or less will not be accepted, where they will be sent for repacking. Okay, so let us read the question A, part 1. Find the mean number of packets of chips marketed if the company produces 5,000 packets of chips. Okay, this is for the part 1. For the part 2, if 6 packets of chips are chosen at random from the company, find the probability that exactly 2 packets will be sent for repacking. Okay, this is for the part 2. Okay, let us read the part 3. If a manager chooses 10 packets of chips randomly from the repacking unit, find the probability that he will get more than 2 packets of chips that has the mass below the range. Okay, so this is the question part A. So let me read the question part B now. Okay, a random variable x is normally distributed with x with a normal distribution. Okay, 12 and 25. Okay, this 12 and 25 is actually indicates the mean and variance. Okay, this is a short form for the normal distribution guys. Okay, normal distribution this way can be expressed. Okay, where the 12 is representing as the mean and the 25 is representing as the variance. Okay, so continue to read the question. Given that probability x more than k is equals to 1 over 4 times with the probability x less than equals to k, find the value of k. So this is the overall question. So without further ado, let us begin our discussion for the question 11 part A. Okay, for the question 11 A part 1. Okay, so from here, before move on into the question, ask yourself, is this a binomial distribution or a normal distribution? Okay, if you ask me, I will say this is a binomial distribution. Do you know why? The question itself already gave you a hint, where they mentioned that the packet of chips ranging from 75 gram to 80 gram will be accepted for marketing. Okay, only the mass from 75 gram to 80 gram will be accepted, others will be rejected. That means there is 2 possibilities, is either yes or no, either accepted or rejected. So from here, only 75 gram to 80 gram will be accepted, anything more, anything less will be rejected. Okay, and they already gave us that the number of packets in ratio form. Okay, from here, when you have x less than 75, you have 1, and the ratio of 75 less than equals to x less than equals to 80, which is the one we want, is 97, and the x more than 80 is in the ratio of 2. Okay, so from here, if you notice something, when you plus all the ratio, you will get a total of 100. Okay, just want to let you know. So in the question, they already gave us that find the mean number of packets of chips marketed if the company produces 5,000 packets of chips. So from here we know that, okay, in this question we are literally discussing about binomial distributions. Okay, so within this binomial distribution, our number of trials will be 5,000. Okay, 5,000 packets of chips. Okay, and then the next thing we should know is the probability of success. Okay, the probability of success, which I denote that as the small letter p. So from here, the probability of success that we wanted to find is the probability where your mass of packet is between 75 gram to 80 gram, which in this case in the expression of ratio. Okay, so from here 97 okay, and then you divide with the total ratio. So 97 plus 1 plus with 2, so from here you get the 100. So from here 97 you divide with 100, so from here you get your probability of success is equals to 0.97. okay, so this is your probability of success. If let's say if the question asks you to find the probability of failure, okay, probability of failure is very simple, 1 minus with the probability of success. So from here in this case 1 minus 0.97, so from here you should get your probability of failure is equals to 0.03. okay, but then in order to calculate the mean, you no need to apply the probability of failure, you just need to use the number of trials and then you times with the probability of success, and from there you should get the mean. Okay, let me write the formula here. So to calculate the mean of a binomial distribution, okay, will be equals to number of trials times with the probability of success. Okay, so from here mean will be equals to 5000, okay, and then you times with the probability of success, in this case 0.97. okay, so let us calculate this together. So from here 5000 times with 0.97, so you calculate this, you should get 4850. okay, so from here you get your mean is equals to 4850 packets of chips. So this is your answer for the question A part 1. So let me underline this. Okay, so we're done with the discussion with the question A part 1. So from here let us move on to our discussion for the question A part 2, where question A part 2 we are required to find if 6 packets of chips are chosen at random from the company, find the probability that exactly 2 packets will be sent for repacking. Okay, so this statement I want you to read it carefully, guys. Okay, because in this case your probability of success is you want them to be sent for repacking. What does that mean then? Okay, that means you don't want your your packet of chips within the range. Okay, that means let's say in the previous question the packet of chips should be within 75 to 80, right? But for the question A part 2 you don't want to be within 75 to 80. Okay, you want out of range. Okay, so from here for the question A part 1, the one which is in the probability of success will be the probability of failure, and for the one which is in the probability of failure will be the probability of success for the question A part 2. Okay, so I hope you understand what I mean, guys. Okay, because the case are different now. In this case we want to find the probability where will be resent, will be sent for repacking, because it is out of range. We want out of range for question A part 2. Out of range in this case is 3/100. X less than 75 out of range, X more than 80 out of range, 75 less than equals to X less than equals to 80. This is within range. Within range we don't want for the question A part 2. So from here 2 plus 1 3, and then you divide with 1 plus 97 plus 2, 3 divide with 100. So from here your probability of success for question A part 2 is 0.03. Okay, let me highlight this again. Okay, question A part 1 and question A part 2 is totally a different scenario. Okay, so from here probability of success in this case it will be 0.03. Okay, probability of failure will be equals to 1 minus probability of success. So from here your probability of failure will be equals to 0.03. 0.97. Okay, this time you want to find probability of the packet of chips which is out of range. Okay, and then the question already highlighted us number of trial is 6. Okay, and we want exactly 2 packet of chips which is out of range. Okay, so from here probability x equals to 2, okay, will be equals to, okay, out of the 6 number of packet of chips, you wanted 2 to be sent for repacking. Okay, and then times with the probability of success square times with the probability of failure 0.97. okay, and from here 6 you minus with 2, so from here you're left with power of 4. So from here probability x equals to 2 will be equals to, okay, let us do the calculation. 6 choose 2, okay, so from here 0.03 square, okay, and then times it 0.97 power of 4. Okay, you calculate this, maths error. What's wrong? Okay, let us try again. 62 0. Okay, 0.974. What's wrong? Okay, let us do it one by one. 0.03 square times it 0.97 power 4. Okay, and the following answer, and then you times it 6C2. Okay, so from here you get 0.01195. okay, even though we face some problems in the calculation, but the important thing, we need to do the problem solving. Okay, just wanted to give some of my little experience as an engineer. Okay, anyway, let's back to our topic. So from here we get our probability x equals to 2 is equals to 0.01195. okay. So this is the answer for the question A, part 2. So let me underline this. Okay, so we're done with the question A, part 2. Let us proceed our discussion for the question A, part 3. Okay. For the question A, part 3, if a manager chooses 10 packet of chips randomly from the repacking unit, find the probability that he will get more than 2 packets of chips that have the mass below the range. Okay, now we need to find the probability that the manager will get more than 2 packet of chips that have the mass below the range. Below the range means more than 2 packet of chips which have mass below the range means, in this case they are highlighting the one which is x less than 75. okay, the one below the range, this is x less than 75. The rest is above the range. Okay, above the range or within the range. So x less than 75 is the one is below the range. Okay, so from here, and you have the number of trials is 10. Okay, question A, part 3 also a different case. So let me highlight it from you. So within this statement, we know that our number of trials is 10. Okay, for the probability of success, since we are emphasizing the packet chips which is out of, below range. So below range, since we are represented by the ratio of 1, so from here 1 out of the 3 ratios, okay, you have 3 types of ratios over here, and only one ratio is out of, is lower than the range. Okay, so from here 1 will be divided by 3 over here. So from here your probability of success will be equals to 1 over 3. So from here, this mass is below range, this mass is within the range, and this mass is above the range. So the ratio of below the range is 1, okay, and the rest is within and above the range, which is 2 over 3. The mass above, the mass below the range is 1 over 3, and the remaining is 2 over 3. Okay, sorry if I've confused you. Just stick to the below range is 1 over 3. Okay, and then for the probability of failure, okay, 1 minus is 1 over 3. Okay, guys. So from here the probability of failure will be equals to 1 minus 1 over 3. So from here you get your probability of failure, which in this case is 2 over 3. Okay. So from here, and we are required to find the probability that he will get more than 2 packets which is below the range. Okay, more than 2 packets. So from here, to get a probability of packets of chips which is below than, more than below than 2, okay, more than 2 which is below the range. Okay, so from here you can do this. There are 2 ways. One, you can start by doing it like x more than 3, x more than 4. You can do like that. Okay, because you have 10 chips, right? Okay, 10 chips means, okay, x more than 3, x more than 4, x more than 5, x more than 6, 7, 8, 9, 10. You plus them all. Or you can do this where 1 minus with the probability of x less than equals to 2. Okay, which one is better? Okay, I will recommend you the second one is way better than the first one. Okay, because the first working is way longer. Okay, it is time consuming. So from here, the probability of x more than 2 is also equals to 1 minus with the probability x less than equals to 2. Okay, basically they are just the same. So from here, 1 minus with the probability x less than equals to 2. So what are the possibilities that we can fulfill for the probability x less than equals to 2? So you can have your probability where your x equals to 0, okay, minus with probability x equals to 1, and then you can also have the probability where x equals to 2 itself, because you have the equal sign over here, so that means you must include the 2 as well. Okay. Let us do the calculation. So from here, 1 minus 10, out of the 10 you choose 0. Okay, so from here 1 over 3, okay, to the power of 0, okay, and then times it 2 over 3 to the power of 10. Okay, and then minus with, out of the 10 you choose 1, okay, and then times it 1 over 3 to the power of 1, okay, and then times it 2 over 3 to the power of 9. Okay, this is the calculation for probability x equals to 1. Okay, and continue with the last one, probability x equals to 2. Okay, minus with, out of the 10 you choose 2, okay, and then times it 1 over 3, okay, square, times with the coefficient of the success, okay, how much you are choosing, okay, and then times with the 2 over 3 to the power of 8. 10 minus 2, and that's how you get the 8 over here. Okay, so you calculate everything. So from here you should be getting 1 minus, okay, for the probability x equals to 0, you should be getting 0.0173. Okay, for the probability x equals to 1, you get 0.0867. Okay, for probability x equals to 2, you should be getting 0.1951. So you calculate all of them. So from here, 1 minus 0.0173 minus 0.0867 minus 0.1951. Okay, convert it to decimal. 0.7009. So this will be your answer for the question A part 3. Okay, so let me underline the solution. Okay, so I hope you understand the discussion for the question A itself. Okay, basically question A, a short summary, is a binomial distribution. Okay, so each sub question has their own different cases, guys. Okay, just because they give the same question doesn't mean the probability of success and failure will be exactly the same. Okay, it may differs according to the scenarios. Okay, so we are done with the question A. Let us move on to the question part B. Okay, for the part B, so for the part B, we are required to find the coefficient k, and they gave us the information where probability x more than k is equals to 1 over 4 times the probability x less than equals to k, and we are required to find the value of k over here. And just want to confirm you, this x variable is normally distributed with a mean and variance of 12 and 25 respectively. Okay, so from here, this is the general term if you want to write in a normal distribution. So x can be expressed as a normal distribution, mean, variance, square. Okay, so in this case, since they give x can be distributed with a normal distribution of 12, 25, so from here we can conclude that our mean is actually 12. Okay, and then our variance is equals to 25. Okay, so from here, to find the standard deviation, what you do, you square root the variance. Okay, square root variance. So from here you get your standard deviation is equals to 5. Okay, we get all the basic informations. Okay, step number 1, you find the mean. Step number 2, you find the standard deviation whenever you encounter a normal distribution. And then the third thing is you need to find some relation of the x. So in this case, x is expressed through the variable k. Okay, in this question, they gave us the relationship that probability x more than k is equals to 1 over 4 times with the probability x less than equals to k. So from here, let me box this. Okay, for the next step, what I'm going to do is I'm going to sketch a bell curve. Okay, a quick bell curve. Okay, so from here, let me just write here k. So from here, so under this region, we can literally conclude that your probability where your x is more than k, that is for the right hand side region, whereas for the left hand side region over here, we can conclude that your probability is x less than equals to k. So from here, as we know that the summation of area under the graph for the probability must be always equals to 1. So from here, we can express that probability x less than equals to k plus with probability x more than k is equals to 1. Okay. So from here, what we're going to do is, since we have the relationship where your probability x more than k is equals to 1 over 4 probability x less than equals to k. So what we're going to do, we're going to standardize this equation into one single variable. So from here, we're going to use x more than k. So in order to relate x more than k, which in this case is over here, so what we're going to do, so this so this 4 we're going to times it over to the left hand side, okay, because probability x less than equals to k plus with probability x more than k is equals to 1, okay, and then they gave us the equation here that probability x more than k is equals to 1 over 4 probability x less than equals to k. So in order to express probability x less than equals to k, so you need to times 4 with probability x more than k, so that you can substitute over here. Basically, you treat this as two variables. From out of the two variables, you need to reduce it into one single variable. Okay, so from here, instead of writing probability x less than equals to k, so we're going to equate it as probability x less than equals to k will be equals to 4 times it probability x more than k. So for the upcoming step, this will be your working where probability for probability x more than k plus with probability x more than k is equals to 1. Okay, for probability x more than k plus with probability x more than k, so you get 5 times with the probability x more than k is equals to 1. Okay. So from here, 5p x more than k is equals to 1. So to find the probability x more than k will be equals to 1 over 5. 1 over 5, when you convert it into decimal, will be equals to 0.2. Okay, so this 0.2 is the area under the graph, which is the probability value. Okay, so what you need to do is you need to check through the Z table, and then you need to check which value is correspond to 0.2. You need to look through the Z table, and then you need to check which Z value correspond to the probability 0.2. Okay, and then from there you need to get the Z value, okay, from Z table. Okay, you get your 0.2 value is equal to 0.842. Okay, and from there you can find your respective x values, which in this case the variable k. So from here, k minus with 12 divide with 5. Okay, this formula is related to x minus mu divide with sigma to get the z value. Okay, and the z value we get from the Z table in this case is 0.842. Okay, this 0.842 correspond to the probability of 0.2. Okay guys, okay, this value for your information we get it from the Z table. Okay, so k minus 12 divided with 5 is equal to 0.842. So from here, k minus with 12 is equal to 0.842 times with 5. So from here get is 4.21. So to get a k, what you do, 4.21 you plus with 12. So from here you get k is equals to 16.21. So this is your answer for the question part B. So let me underline the solution. Okay, so let me scroll the question up. Okay, we have come to the end of our discussion for the SPM 2021 paper 2 question number 11 and also the section B discussion. Okay, if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming Add Maths tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.